so just like in the beginning of the course when we learned how to do the mean and the standard deviation of data, we then had to learn, well, what happens to the mean and the standard deviation of data if you do certain things, like if you add or subtract a constant, or if you multiply by a constant. So we learned that with regular data, and now we're also going to learn it with random events, with random variables as well, not just regular old data. So when we add or subtract a constant from data, it shifts the mean, but it does not change variance or standard deviation. That is the same concept as earlier in the year. Adding and subtracting constant just kind of picks up all the data and plops it down, so the mean shifts, but the data does not become more or less spread. Now, I'm going to write this out, and it's going to look a little funny at first. But what this is saying here, you got to get used to what this is saying, is the mean or the expected value of the variable plus the constant is just the mean of the variable and then add the constant. So what that means is you don't have to go add the constant to all the individual x's and then redo the formula. You can just know that it's going to work out that you can just add the constant to the mean. Now, for variance, it's just simply equal to the variance of x. Notice there is no plus or minus c on that one. The plus or minus c has no effect on the variance. Same thing with the standard deviation. There's no plus or minus c. The standard deviation of a random event plus or minus a constant is just going to be the standard deviation of the random event in the first place. So let's take our example back to our Lucky Lovers discount. Suppose that the local restaurant running the Lucky Lovers special has also been distributing coupons worth $5 off of any one meal, one discount per table. If every couple dining there on Valentine's Day brings this coupon, what will the mean and the standard deviation be of the total discounts they'll receive? So let's remind ourselves that the mean and the standard deviation of the Lucky Lovers discount was $5.83 and $8.62. So now what they want to know is if we're going to add $5 to everybody's discount, what will the mean be for this and what will the standard deviation be? So what I'm kind of doing is setting up D plus 5 as the discount plus $5. So we're adding a constant. Hopefully you realize that you could take your probability model from the first problem. You could just go add 5 to each of these numbers, make it 5, 15, 25, and then redo this formula. You will get the same answer that I'm going to get right now by just simply taking the previous discount, the D discount, and just adding 5 to it. Check it both ways. If you just don't believe it, you will get the same thing. Same thing for the standard deviation. If you want to, you can go make all of these 0, 5, 15, 25. Redo this formula to get a new mean. And then redo the long, crazy standard deviation variance formula to get the new standard deviation or variance. And you will get the exact same answer as we got the first time. Do it if you don't believe me. Double check it just to make sure it is a true statement. That adding 5 does affect the center or the mean, has no effect on spread. So the variance would still be 74 or whatever it was, and the standard deviation is still 862. Now, what about multiplying? A little bit different. Multiplying each value of a random variable by a constant will multiply the mean by that constant. It'll multiply the variance by the square of that constant, and it will affect the standard deviation by multiplying by that constant. So just like when we were doing regular data, multiplying affects everything. Just be aware if you're dealing with variance, it multiplies by the square of that constant. Because remember, everything in the variance was squared, okay? So written in general terms, now I'm finding the expected value of some constant times x. That new answer will just be that constant times the old expected value. The variance of some constant times x will be that constant squared times the original variance. And the standard deviation of some constant times x will just be that constant times the original standard deviation. So back to our lucky lovers discount. When two couples dine together on a single check, we're going to go back to the original problem where the mean was 583 and the standard deviation was 802. If they dine together on a single check, the restaurant will double, that means times 2, the discount. They will double the discount. Yet again, you can go back to your original probability model and you can double all the discounts, 0, 20, and 40, and redo the formulas. But you don't have to do that if you know the relationship. So what will the new mean and standard deviation be? So now we're doing 2D, and that does affect the mean. You will just simply double the mean. Go to my calculator and type that in. 1166. And it does also affect the standard deviation by just doing 2 times the old one. If we would have done variance, we would have to have done 2 squared, or 4 times the old variance, 1724. And that's your shifting and scaling. Just like we did earlier in the year, shifting affects the sender, has no effect on variance or standard deviation. Rescaling or multiplying affects everything. And then remember, for the variance, it affects, you multiply the variance by the square of the constant.